My name is Luigi De Bernardini. I'm the CEO of Autoware, and I welcome you to this presentation about Operations Control System, the new frontier of MES. Before starting to talk about OCS, I would like to spend just a couple of minutes introducing my company. Autoware was founded in 1996 with the goal of developing software for production management. Starting from the early beginning, we established a strong partnership with Wonderware, and in 2001 we defined three specific business units to focus better on our expertises, and the three business units were manufacturing execution systems, industrial automation, and machine vision solution. Another important milestone for our company was 2008, where we started an internationalization program, becoming a business unit of Automation Alliance Group, a consortium of companies, system integration companies, that has its goal to provide global coverage and local support to customers. And we became even an active member of CSIA, the only one system integration company association that defines the best practices to manage a system integration company on a 360 degrees perspective. We work in many industries. We do not have any very specific vertical expertise. We work in food and beverage, in healthcare, in manufacturing, in metals. We work with OEMs, and we work even in many other industrial sectors. So we had a wide spectrum of experiences without any vertical, very specific expertise. We work and collaborate with several clients, local small companies and global multinational companies as well. So we are structured to service a very different range of clients. But let's start talking about OCS, Operations Control System. And let's do that taking in a short trip through the evolution of control systems. Let's start from the 60s years, where control systems were mainly electromechanical, characterized by high complexity even to perform simple tasks. They had a very high speed of response, but they were terribly rigid. It was almost impossible to change the logic governing the process, or it was terribly expensive in terms of time and money to do that. In the 70s, something changed, and the main thing was that this guy, Dick Morley, installed the first PLC at the General Motors Oldsmobile. Looking at that device from our days, it's a very low performance device, but it introduced a new element in control system: flexibility and configurability. So the ability to change the logic that controls the process in an easy and user-friendly way. In the 80s, we see the coming of personal computers. They are small size, low cost, low performance devices, but they are easy to program, and this enables to think to a new utilization of this kind of devices even in the industrial world. In 1992, the timeline of the control system intersects my personal experience as I start to work in an industrial automation company. And what I face from the beginning is that the PLC is taking over the electromechanical logics. There are still some dedicated analog boards to perform control tasks, especially speed control or synchronism between motors and so on. But almost all the complex logics are in charge of the PLC. The cost of the CPU is reducing, the flexibility is increasing, and the programming tools are absolutely becoming user-friendly. And this enables a wide number of users to develop programs to perform process control. On the other side, the human-machine interface is many times still developed using aluminum boards with LEDs or lamps to indicate the status of the devices. 1996, as I told you, we start Autoware, and we start to develop SCADA systems, and SCADA systems are going very fast to take over the aluminum panels because they enable the development of complex synoptics, they enable to start to do some data management, they make the process management task easier for the operators, and mainly, again, they introduce flexibility and reliability. 1998 is an important year for us. We developed the first performance control system or performance measurement system. It's a pretty simple system, but it manages downtime management, it manages good and waste count, it provides real-time information to operators, it replaces almost all the paperwork in the company to collect this information, and it permits the company to increase the efficiency by about 30%. Why this is important? It's important in my opinion because the focus for the first time, at least for us, is not anymore in the process control, but it's in the process performance measurement, which is something completely different from the beginning. 2001, a new step further, we created the first complete MES system. The focus is not anymore just on performance management, but this MES system manages raw material, tracking, tracing, production order dispatching, identification, efficiency of course, and it interfaces with the warehouse management system to upload the data regarding the finished goods. So again, this is important because the focus in this case is not on the process, but it's on the coordination of different processes that constitute the operations. What about 2011? What have we to expect? Well, we all know the pyramid of control. It's a well-known pyramid, 3-layer pyramid, where at the bottom we have the process layer. It's a layer of devices, it's a layer of actuators. In the middle we have the control layer. It's the layer where the PLC implements all the process rules and all the process control. And then on the top we have the SCADA layer. It's a layer of where the information are presented to the user, where the input are collected, and where the information are displayed. During time, this pyramid evolved, and all the control pyramid that we just saw is embedded in a new bottom layer, which is called shop floor layer. On the top we have the ERP, which is the layer of strategic decision in a company, and in the middle we have the gap that is normally filled by MES, or has the MESA, the Manufacturing Execution System Association, now start to call MOM, Manufacturing Operations Management Systems. And these are systems that have as a goal to fill the gap between the shop floor and the ERP and make these two different worlds communicate each other. What are MES systems? There are many different definitions that you can find about them. They vary from the very easy definitions like the one that you can find on Wikipedia that focus on the different functionalities of MES systems, to more business and related and complex definitions like this one from the Gartner Group, to a description in terms of a standard model that was approved by the MESA, which defines the MES system in terms of data, relationship, flows of information. But the definition that I like more is the definition that one of our customers provided. And he said in 2002 that MES means meglio esserne senza, which translated in English is it's better to be without it. But in 2007, for him, MES was mai esserne senza, which means never be without it. And in my opinion, this is a measure of how much important an MES system become in a company. So important that the company itself feels that it cannot work without it anymore. The market of MES system is still a growing market. There are a lot of potentiality in it. From this study, from an analysis of Frost and Sullivan, the market in 2009 was about $3.6 billion, and is going to become a market of $8.2 billion in 2016. So it's going to double in almost 5 years. So there's a lot of work to do in implementing MES systems, and there's a lot of space working on them. But MES systems are even showing some limits, and the limits are mainly related to some staticity, especially if compared to an organizational environment that is changing frequently and terribly fast. Many actions are still dependent, even if the company has an MES system, on human factor. There's no guarantee, about responses, and the flow of information and decision is just partially managed. Or, on the other side, all these things can be accomplished, but all these activities and all these rules has to be hard-coded in the system. While today the market is requiring quality, for sure, is requiring a certainty in terms of information, in terms of responses. It's asking for cost reduction to all the companies to survive in the market and remain competitive. It's requiring the companies to be independent by the people. The experience cannot be anymore only in the brain of the technicians or of the people working for the company, but has to become property of the company itself. The market asks for speed in answering the inputs from the market. It's asking for efficiency, but mainly it's asking for flexibility. It's asking the organizations to be flexible and very fast in adapting to the always changing market conditions. So, fortunately, there are some technologies that are, let me say, new, and that can help companies to achieve and to respond to this request from the market. These technologies, as always happens, are well known in a different level. They are well known at the ERP level, and they are known as business intelligence and business process management. As always happens, as the technology improves and goes further, these technologies become available at a lower level, and becoming available at the MES, in this case, level, they change their name. And the business intelligence is called now manufacturing intelligence, and the business process management and workflow management when we talk about them at the MES level. What is manufacturing intelligence, or MI? Manufacturing intelligence is typically a suite of software tools or applications that enables the integration of different data coming from different worlds with different granularities, and use this data to generate new information that were not available before. The important things in terms of manufacturing intelligence systems is that they are able to aggregate data that have a very different granularity. A small granularity for the data coming from the shop floor, and a big granularity data coming from the ERP or commercial system or CRM or other systems that are available in the company. And all these data are aggregated, correlated, and generate new information. And today, some technology providers start to offer manufacturing intelligence system in addition to automation system and MES systems. And this allows to integrate the data from different systems and generate new information. And this information, and this is the important things, are made available to the users in time for taking decisions about how to manage operations. So the users who are in charge of operations management can rely on a new set of information that arrives them in real time and that were not available before. What is BPM, or workflow management? It's a tool or a suite of tools that helps organization to cope with frequent process changes, because a workflow management system make the description of process easy and make the description of process explicit and visible. And these tools enable the users, enables the companies to modify the description of the process in a very flexible and fast way. And even in this case, many technology providers today are starting to offer workflow management system in addition to MES system or automation systems. And this allows the company to implement rules and logics related to organization and to business tasks in an automatic way, even inside or related to MES system, which are much more close to the shop floor. So we have three combined technologies available. We have the MES system, we have the workflow system, and we have the MI system. And these three technologies constitute three different layers. So it's pretty easy, simple, to create immediately an analogy with the control pyramid. And we have a new pyramid available today. We have a pyramid where the MES layer is the bottom layer. It's absolutely analog to the process layer. It's the layer where we have the execution and control, not of the process in this case, but of the operations task. We have the workflow layer, which is almost identical to the control layer. It's the layer where the business, the operations rules are processed. And then we have the MI level, that is equivalent to the SCADA layer. And it's a layer of presentation. It's a layer where data are inputted by the operator. It's the layer where the information are generated. And this information can be triggered can be used to trigger rules at the execution layer. So, as we saw before, where the standard original control pyramid was embedded in the shop floor level, we have this new pyramid that is composed by the MES layer, the workflow layer, and the manufacturing intelligence layer that becomes itself a new layer. So the layer that was before the MES layer can now be considered the OCS level, the Operations Control Systems layer. So operations control systems, they are automatic control systems of the operation. They are systems that provide the possibility to model in a very flexible way the rules that manage all the operations. And moreover, they are systems that implement and run these rules in an automatic way. And automatically and controlled way. So the rules are now, the company do not need to rely anymore to the goodwill of the operators to have the rules followed or implemented or the action taken, but their implementation is guaranteed in the way and in time of execution by the OCS, so by the operations control system. And all the decisions, all the rules, all the flows of decisions and of information are tracked and documented. Let's see an example. And we've chosen an example that is related to a maintenance flow, and this example starts from a terrible accident of a windmill in a food plant. So the windmill collapsed. What was the cause of the accident? Well, the cause of the accident was a maintenance problem. They had repeated alarms that indicated an abnormal situation, and these repeated alarms triggered a maintenance procedure. So the maintenance technicians were advised by email or by SMS by the system, and they step in and solve the problem. But what went wrong? The technicians that solved the problem didn't reflect the changes in the documentation of the system. And this enabled two possible situations. One, that if he had to do a different maintenance job on the same system, he could forget of what he did before. But what really happened was that a different technician had to work on the system later, and he took some wrong decision because the documentation was not updated, so he had not all the information he needed to maintain the system and do his job. Moreover, the system was running even if it was not necessary, because if the production planning manager could analyze data coming from the production scheduling, from the energy management system from the shop floor and could analyze this data altogether, he could inform the plant manager that the windmill was not necessary anymore and it could have been shut down. This probably just could postpone the accident, but in any case it could be avoided. So the error was not caused by a bad management of the flow of alarms or of the activity. It was caused by a bad management of the workflow related to the activities that were triggered by the alarm, and in particular by the documentation management. So what could happen with an OCS system in place? Well, the beginning is the same. Repeated alarms indicate an abnormal situation and lead to the start of a maintenance procedure. The maintenance technician are advised by email or by SMS, as before, but at the same time, even the plant manager is notified of the failure of the machine. And a technician can take ownership of the task, and he could perform all the activities to replace the wrong components or to the faulty components, but the system drives the technician to update the documentation and guarantee that the task is not completed before all the steps are completed. So the system itself guarantees that the documentation is updated with the latest information, so to guarantee that the future maintenance activities can rely on updated documentation. The system can even provide some features to escalate in case a technician do not answer to the call in the time that is defined by the company, and the plant manager itself, if it's not notified that the maintenance activity has started, can define or involve a different technician and guarantee that all the activity is performed in the times that comply to the business policies. But more than this, the manufacturer intelligence tool, aggregating data by the production planning, by the status of the lines from the shop floor, by the energy management system, could elaborate all this data and generate a new information that defines that the windmill is not necessary at the moment. And the production planning manager could be notified of this information, and the system could guarantee that he informs the plant manager about this situation. Or the system could inform the plant manager automatically using the information generated by the manufacturing intelligence tool. And this could lead to shutting down the windmill and avoiding the risky situation. So we saw that the benefits of implementing or of having an OCS system in place is the ability to be reactive to inputs or situation that triggers activities, to have the guarantee of a response, to have the guarantee of being compliant with the company and with the business policies that are not anymore in the brain of the operators or of the people working for the company, but are defined and described and implemented in the system. Reduction of bottlenecks. People are not bottlenecks anymore because the system takes charge of avoiding bottlenecks escalating and guaranteeing that tasks that has to be performed are performed in the right time. Independence from people. Guarantee of information, providing the right information in the right time, in the right places, and automatic response. That's all about OCS, about our idea of the new frontier of MES that integrating these three new technologies can bring to a new class of systems, the operations control system. If you need any further information, if you have any doubt or any curiosity, if you want to talk with us about this vision of the future of MES system, please do not hesitate to contact us. We will be more than happy to answer all your questions and to provide you any further information you should need. Thank you very much for attending this presentation.